So see, there is this simple question. If you are able to solve this simple question, let's say and this question will clear your concept. It will clear your doubts. So this is a 4 ohm. You have 12 ohm over here and 8 ohm here. So I think you are very well aware. First question, you need to compute the average, first compute the equivalent resistance. In this diagram, you need to compute the equivalent resistance. Let's see what all things we need to compute here. Calculate equivalent resistance. So have you calculated the equivalent resistance?
1 minute.
You just compute the equivalent resistance. Then you need to compute total current drawn from the battery. And then potential difference across each resistor. Potential difference across each resistor. And then you need to find current through each resistor. So these are the 4 points you need to compute here. We are given the, let us have the battery has a voltage of say 12 volt. Let us suppose we have a battery of 12 volt, right? So who has obtained the answer for the equivalent resistance? I think everyone should have obtained the value for equivalent resistance. Mehak, what is the value you are getting for equivalent resistance?
4.20.
4.20. Okay, how you have computed that?
Sir, for parallel, I did 1 by 8 plus 4. So I made a mistake.
Yeah, I know what is the mistake you have made. I know. You have not reciprocal, you have not made the reciprocal of that.
Yes, sir.
So that is the most common mistake that students make. Everyone see, this is the most common mistake everyone does. If you are computing here 1 by R, so 1 by R equivalent to 1 by R1 plus 1 by R2. Most commonly we do complete up to here 1 by R equals 1 by 8 plus 1 by 12. We take the LCM being 24. Here we will get 3 plus 2, that's 5. So 1 by R is this much. 1 by R we get as 5 by 24. Okay. So we take this just as R only. This is not R. This is 1 by R. Okay. You need to convert it. To convert it to, you need to reciprocate it. So in the reciprocal, the parallel combination, you will get this as 4.8 ohm.
Sir?
Yes.
Sir, good evening, sir.
Good evening.
Sir, I was not able to join, sir, so I came a bit late. So can you tell what are we doing, sir?
This is the question from electricity which we are taking. Most of you had the doubt from the electricity chapter.
Right, sir. Okay, sir.
Okay. So we are trying to resolve the doubts, whatever problems you are facing. I think in this question, your more than 50% of the doubt shall be solved. Okay. So everyone has got this, the resistance of the parallel combination. Since every time we make the mistake, the solution to the problem is that you write the complete equation. Okay, the error why the error arises? See, Mehak can check her copy. The error is due to she had not written this 1 by r at each step. Just up to here she had written, and she got 5 by 12, and then she thought that the answer is 5 by 12, 5 by 24. Okay. So that is the most common error. You have to write it completely. At each step, write here 1 by r, write here 1 by r, write here 1 by r. Okay. Or your another alternative to this is you directly remember the formula as Rp will be equals to R1 into R2 divided by R1 plus R2. Either you remember this one also. Okay. So I have got one question. Okay. So we'll be doing that only. This is from Charvik. Okay. So Charvik has sent one of the doubts. After this, we will be taking that doubt. Okay, so R we have obtained, this is the resistance of the parallel combination, and equivalent resistance will be equal to 4 plus 4.8, that is going to be 8.8 ohm. This is the equivalent resistance. What is the total current drawn from the battery? Dhananjay, what will be the total current drawn?
Sir, but the parallel equivalent resistance should be 1 by 4.8, no, sir.
No. Okay. This is your RP, not 1 by RP. This is RP, resistance of the parallel combination we completed. RP is 4.8.
Okay, sir, you already did it, sir. Okay,
Yeah,
sir.
I did it. So this was the second time I was writing it.
Yes, sir, yes.
Okay. So Dhruv, Dhananjay, have you obtained the Dhruv is here?
Sir, I
Yeah,
obtained
sir,
it.
I'm here. Okay. So Dhananjay, what's the answer for the total current drawn from the battery?
So 1.36 ampere.
1.36. Okay, so total it will be 12 by 8.8. So whatever you get, this is your 12 by 1, 8.8 ampere of the current. Then potential difference across the each resistor. What will be the potential difference across each resistor?
Sir, so in this circuit, the current will be constant in every part of the circuit until 4 ohms, and then it will break to the 2 resistor.
Okay. So through this 4 ohm resistance, the current flowing is 12 by 8.8. Okay. If you simplify this, it will be 120 by 88. And this comes out to
0.36.
be somewhere 30 by 22, 15 by 11.
1.3.
Okay, 1.3, whatever you are getting, we'll see that is 15 by 11 ampere. Okay. Now PD across each resistor. What will be the potential difference across the 4 ohm resistor?
5.2 volt.
0.34.
How much? How much?
Sir, I got 0.34. Sir.
Okay, so this would be equal to IR, where I we have 15 by 11 and this multiply by 4. So this 60 by 11.
Sir, I got 5.44.
Yeah, 5.44 is the correct one. 60 by 11 is over here. And then we can compute the PD across the second one. PD across the second resistor would be, you have the equivalent resistance as 24 by 5. So this is your V1 and the second potential V2 will be equal to IR, where I is I we got 15 by 11. Okay, just wait 1 minute first. Okay, so I'm back now. You can start. So see, V2 will be again I times of R. I is 15 by 11 and the resistance of this combination we got as 24 by 5. So this is 24 by 5. 5 times 3, 15, and then multiply 72 by 11 volt. Now see, it's when it looks very confusing. If you add this V1 and V2, add this V1 and V2, and let's see, are you getting 12? Add V1 and V2. See, V1 and V2. If you add V1 and V2, you will get 60 by 11 plus 72 by 11, and this will be equal to 132 by 11. You
Which is
divide
12.
it, which is 12 volt. So that means our all the calculations, everything is correct.
Then how did you get 24 by 5?
Sir, do we not take it for just the 12 ohm resistor and then just the 8 ohm resistor?
See, what is happening? This first resistance R1, which is 4 ohm, this is connected in series with this complete combination, right?
Yes, sir.
And when two resistances are connected in a parallel combination, in series combination, then the potential drop occurs. Okay, so that means first resistance will have some other potential and the second resistance will have some other potential. Okay, it will have some other potential, let's say V2. So it will have the potential V2 and this will have the potential V1, and we know that in the series combination the total potential V is given by V1 plus V2.
Okay.
Okay, so
Yes.
both the systems, they will have different potential. 4 ohm will have a different potential and this parallel combination will have a different potential. But in the parallel combination, the 12 ohm and 8 ohm, they both will have both 12 ohm and 8 ohm, they will have equal potential and same potential. Their potential will remain the same.
Okay.
Okay, so potential for 12 ohm is also same. Potential for 8 ohm will also remain the same, which will be equal to V2. But for V1 and for 4 ohm and 12 ohm, it will not be same. It will be different. Okay, so I think your some of the doubts are clear through this discussion of the question. Anyone is having any problem?
No, sir.
No.
No.
Dhruv? Dhanunjay?
No, sir, no doubts.
Okay.
No, sir.
So,
Sir,
so for the yes,
sir, for the 12 volt, you just added V1 plus V2. What about the V3 one?
where is V3?
So the whole is V2, sir.
See, you can see two things to be in the series combination: the 4 ohm and the equivalent of this. Okay, so the equivalent of this is connected to this. The equivalent of this is in the series. So there are just two resistances which we consider in the series. Equivalent means you can remove this 12 ohm and 8 ohm and replace that with a single resistance of 4.8 ohm.
Yes, sir, got it.
Okay. Now the last part, current through each resistor. Let's do the last part, current through each resistor. So first one we already know. We know the current through the 4 ohm resistor, right? How much is the current flowing through the 4 ohm resistor?
0.34. No, sorry,
0,
5.4. 5.5.
How much? 5 point? That's the same answer, 15 by 11.
1.36.
Since in the series combination, current remains the same. I'm not rushing through it. If you are not clear, just get your concepts cleared in this. Get your concepts cleared. Okay. So any doubt? Everything is clear?
Yes.
So who will tell me this? Now see, I think you are having some of the doubts in current through each resistor, but you people are not speaking. Dhruv, what will be the current through 4 ohm resistor?
Sir, 15 by 11 only.
How much?
Sir, 15 by 11 ampere.
15 by 11 ampere.
Yes, sir.
Okay. Then how do we compute the current through the 12 ohm resistance and current through the 8 ohm resistance? Yeah, how do we get that?
Can I say?
Yes.
So we got the value of V2 as 72 by 11, and here resistance is there. So we can consider like V2 by R1 is 6 by 11, and then V2 by R2 will be 9 by 11.
Okay. So that's the very correct answer. How you obtain this? If you want to current the currents, compute the currents there. So here the current is dividing into two parts. You have the current I1 flowing over here. You have the current I2 flowing over here. Okay. So it will be I1 we want to calculate. So I1 will be equal to V by R. V we know that is where V2 which is acting across the 12 ohm resistance. So you have divided it into small systems now. Okay. So this is your other system, this is other system. You have divided them into systems. So in this system, you can consider a voltage of second V2 which 72 by 11. So V2 is 72 by 11 and this divided by R. R is 12. So you divide it by 12. So that means multiply by 1 by 2. That's the division. And get 6 by 11 ampere. So 6 by 11 ampere is what you are getting through the 12 ohm resistor. Okay. You can subtract the remaining current and that will be the current flowing through 8 ohm. Okay. So for your practice, I am giving you one more question, but the question remains the same. Okay. So I am giving you another question. A similar one just, and I think everyone should be able to compute this. Exactly similar, no differences. If you have understood the previous question, you will get the answer to this question. Again, all your questions are same. You need to compute the same thing. This you have a 6-volt battery. This is what you have to calculate the equivalent resistance, total current drawn from the battery, PD across each resistor, and current through each resistor. Okay, so who has obtained the answer for the first one? Equivalent resistance.
I got it, sir.
Okay, so just send the direct message. Mehak, did you get the answer to this? Equivalent resistance?
No, sir, I'm still doing.
Okay. Trilasya?
Yes, sir.
Okay, so did you get the answer?
Sir, I'm still solving it, sir.
Okay. Just equivalent resistance.
I got it, sir.
Okay. So
I
five
sent
people
it, sir.
had, okay, 5 things. Dhanunjay has sent the answer. Very good, Dhanunjay. Okay, so Shravani, Tanishka, uh, Amatur Rahman. Okay, all your answers are correct. You got the correct. Manan has got incorrect answer. Manan,
Sir, that was by mistake. I wrote I
oh,
gave again the correct answer, sir.
okay, okay, fine. You get Mehak. Mehak, you got wrong answer. Why? What happened? Mehak, check your answer once more. Check the solution. How can it be 4 ohm? Yeah, Rene also gave the correct answer. And Dhruv has given all the answers. No, Srilasya, your answer is also incorrect. Srilasya and Mahek, both your answers are incorrect. You need to see here. Just see here. Srilasya and Mahek, see here. I think everyone has got it correct. So those of you who have got it correct, just move on to computing other parts. Okay. See the first one, we need to compute the equivalent resistance. For this, we divide it into two parts. That is this part, which consists of a parallel combination. The first part consists of a parallel combination, and the second part is a single resistance. So the in this parallel combination, the resultant is given by 1 by Rp is equals to 1 by R1 plus 1 by R2. Okay. So we get 1 by R in the parallel combination will be equal to 1 by 6 plus 1 by 12. Taking up the LCM to be 12, you get here 2 plus 1, 3. So that is 1 by Rp. And you get your Rp resistance in the parallel as 12 by 3, which is 4 ohm. Right? So Mehak, did you get this answer?
Sir, I got it 4 oops. No, sir, it's correct.
No, but this is only for this one. What about this 4 ohm?
Okay.
Okay, so we have to include this 4 ohm. So your final answer will be the sum of both of them. It will be R in the parallel, that is we obtained, plus 4 ohm. So 4 plus 4, we have a total of 8 ohm. Yes, Srilasya and Mehak?
Okay, sir.
Okay. Okay. Shravani, you gave the answer total current as 3 ampere.
Yes, sir.
So how are you getting 3 ampere? You have a total resistance of 8 ohm. Total resistance is 8 ohm and your potential difference is 6 volt. So your total current I will be equal to 6 by 8. That's 3 by 4 ampere.
Yes. I found it. I found out the current for each resistor in my article.
For what?
For each resistor, sir. I didn't notice.
So for even if you are going for the each resistance, see, and the basic thing is that suppose I want to find out the current through this 6 ohm resistance. So I must know the potential difference across the 6 ohm resistance. Okay, so I must put up, if I put up a voltmeter over here, I put a voltmeter over here. So will this, what is the potential difference that this voltmeter will show? Will this voltmeter show me 6 volt or anything else? This voltmeter will show me a potential of 6 volt or anything else. It will show me a different potential, not
Yes,
6
sir.
volt.
Yes, sir. Right. I'll
Okay.
correct it.
Okay. So V1, Vedika, how can we get the V1? How can we obtain V1? Since
Sir, 6 plus 12.
6 plus 12. Okay. What is the
Sir,
total
18.
resistance of this? What is the total resistance of this?
Sir, this is 4.
4 ohms. And what is the total
Yes.
current flowing through it?
6 4.
6 or 3 by 4? You are getting the total current flowing as 3 by 4.
sir.
So the total current that is flowing through this complete part is 3 by 4. The total resistance it has is 4. So I can get the potential as V equals to IR. Current I know as 3 by 4. And voltage that is there, resistance is 4. So 4 and 4 cancel. You have 3 volt. Your voltmeter V1 will show a potential difference of 3 volt. Okay. You can cross check it. You can cross check it. Yes.
Sir, my Zoom went unresponding, sir, so I couldn't respond that time. I got the answer as 8 only, sir.
Okay. You got your 8 ohm. Fine. Fine. So you are saying you wrote the answer as okay. Manan gave 3 volt and 3 volt. Fine. So I think everyone has understood this problem. Okay, all of you. I don't think that I need to discuss it all. Is there anyone who has not got it? Who has not got the answer? So that we can move on to the next problem. Okay. So I think everyone has understood. So this next problem, this is a question will try to confuse you. Okay. You will get confused by the question, but if you are clear with the concepts, you will be able to get the answer. Okay. So again, you have a potential of 6 volt. The resistances here, this one is your 15 ohm. You have 4 ohm and 8 ohm. Okay. So here all the questions. Now here the questions are you need to find out reading in ammeter A1. What is the reading in the ammeter A1? You need to find out equivalent resistance. You need to find out current through 4 ohm resistance. Again, very simple questions are these. Current through 4 ohm resistance. A reading of V2 or reading in voltmeter V2. This is your A2. Pick one A. Reading in ammeter A2. So everyone can see the ammeter A2. Sorry. Sorry. Okay. Good night. And the last question you have, will the readings of A1 and A2 be the same? So you need to do all these.
चलो बैठो
So I think if you are able to do this, your almost all the doubts will be cleared, and after this we'll be just left with calculation of energy and power. Okay, Dhruv has sent almost all the answers, and one of the answers of Dhruv is incorrect. He has not sent a third and fourth. Okay, no need to hurry. Try to attempt it correctly. Okay. Uh, Actually, you need to first solve the second one, and then you can solve the first, or you can even solve the first one directly.
Yes, sir, we
Reading,
can.
reading of the emitter A1. This is 6 by 15, which you get 2 by 5. So this will be equal to 0.4 ampere. Yeah, Shreyasi, did you get this answer? First one. Srilasya? Srilasya, did you get the
Yes,
answer?
yes, 0.4.
It's 0.4. So
Yes, sir.
Dhruv, did you got where you were wrong? See,
yeah
the
sir I
fifth,
took the resistance as 20 by 3
yeah. So the emitter A1, it will represent the current flowing through the branch 15 ohm. Okay. And 15 ohm and the equivalent of these, they are connected in parallel combination. And in the parallel combination, potential remains the same. So 15 ohm and this branch, you can consider it like this. There are two branches, let's say branch AB and branch CD. So branch AB and CD, both of them, they are connected in parallel, okay, to a battery of 6 volt. So the potential difference across AB will be 6 volt, and the potential difference across CD will also be 6 volt. Okay. So that is why we get the answer as V by R 6 by 15. That's the reading of this emitter for 0.4. Then equivalent resistance R. what will be the equivalent resistance R? Equivalent resistance. The second one, we can compute the equivalent resistance. First, in the series combination, you have 8 plus 4, which is 12. So you get your answer as 1 by R will be equal to 1 by 12 plus 1 by 15. Taking out the LCM, which is 60, you get 4, 5 plus 4. Right? I'm writing 4 plus 5. You get 5 plus 4, that's 9 by 60. This is 1 by R. And you will be getting your R as 60 by 9. This is the resistance 60 by 9, which means 20 by 3 ohm. So this, I think many of you have sent correct answers as 20 by 3.
So current through 4 ohm resistor will be the same as the current in the entire circuit, right, sir? Because it is in series.
Current through 4 ohm will be same as the entire circuit. Okay, how can it be
Like
the
it will be
same?
equal to the reading shown in A2, right, sir?
Okay, see here, see. See, suppose some current I is coming
For
from the
4 and
battery.
8 only, right?
Yeah. See, this current I is flowing over here. At this junction, the currents divide into two parts. Some part of this current I passes through the part CA and the some part passes through the branch CD. As current is the rate of flow of charges. So here, suppose here 10 electrons are coming. So out of the 10 electrons, let's say 6 electrons move through the branch AB, then 4 electrons will be moving through the branch CD.
Ah, okay, understood. Yes, yes.
Okay? So they will have different currents. So here we will have some current I1 and here we will have some current I2. So we have got the second answer correct. The second answer is equivalent resistance, which we get 20 by 3. Now current through 4 ohm resistance.
So do we leave it in fraction?
Yeah, leave it in fraction. If it is coming down to be a terminating decimal, so you can complete it. Otherwise, you can leave in the fraction. That's the better way.
Okay, sir.
If it is not terminating, leave it over there. Okay. Now the third one, current through 4 ohm resistance. Okay. So this is a very tricky question. Current through 4 ohm resistance. Everyone see here. I don't know how many of you have sent this answer. Current through 4 ohm resistance. See this. This is a very tricky question. Tricky in the sense they are asking the current through 4 ohm resistance, right? But for that you need to compute the current through this complete branch. You
Yes,
need to
sir.
you need to find out the current through this complete branch CD, as the current in the series circuit remain the same. So therefore, whatever current is flowing through the 4 ohm resistance, the same current will flow through the 8 ohm resistance also. Okay, so both of them, they will have the same amount of current flowing through this, and we know the potential difference across the CD, but we don't know the potential difference across the 4 ohm resistance. Right? If I put
Yes.
a voltmeter over here, so I don't know what the reading of the voltmeter will be. As in the series, the potentials are different. So here, the complete CD branch, it has a potential of 6 volt, and I can find out the current I2. So current I2 I can get as 6 by 12. That's 0.5 ampere. Okay. And since I2 is the current which is flowing through CD, so how much current is flowing through 4 ohm resistance? Manan, how much current will flow through the 4 ohm resistance?
0.5 ampere.
0.5 ampere only. As in the series circuit, current remains the same. So 0.5 ampere will flow through the 4 ohm resistance. Okay. Then what will be the reading of this voltmeter V2? Fourth one, reading of the voltmeter V2.
IR, sir. It will be 8 into
8
8
into
into 0.5. Yes, sir.
8 into 0.5, and this you get as 4 volt. Okay. So you have the reading in the voltmeter V2 will be 4 volt. Now reading in ammeter A2. What will be the reading of the ammeter A2? The fifth one.
0.4 plus 0.5.
So what is that answer? 0.4 plus 0.5?
0.9.
0.9. So ammeter A2 will show you a reading of 0.9. So here A2 equals 0.9 ampere.
So when did we get zero? Acha, okay.
Got it? Or either you get it this way, or you can get it by the formula of taking the equivalent resistance also. You can obtain it by taking the equivalent resistance. We obtained equivalent resistance as 20 by 3. We know the total voltage is V. So by that method also, we can obtain this. Either you can add up the currents I1 and I2. Okay, we have already calculated I1, which is 0.4. We have already calculated I2, which is 0.5. So you can add up them, you will get 0.9. Or if you use the Ohm's law, so by the Ohm's law, you can get it directly that current I will be equal to V by R. V is 6 divided by R, which is 20 by 3. So convert this will become 6 into 3 by 20. So this becomes 10, this becomes 3, you get 0.9 ampere. So both ways it is correct. Now the last one, sixth part. Will the ammeter A2 and A1 show the same readings? Yeah, will the ammeter A1 and A2 show the same reading?
No, sir.
No,
Yes.
they will not show the same reading. They will show different readings. A1 will show a reading of 0.4 ampere and A2 will show a reading of 0.9 ampere. Okay. So I hope a few of your doubts have been cleared up with these three questions, right? Okay. Now let's say a doubt that was sent in the beginning of this class. Let's take up that doubt. After completing that doubt, this class will finish. So, okay, I'm taking out the doubt. Just wait 1 minute. Hmm. Mhm. Okay, I'm resharing the screen so that we can have the access to question. So you have this question. The figure shows three cylindrical copper conductors. So in the first cylinder, you have the length L, area A. In the second one, you have the length 3L, area as A by 3. In the third one, you have the length L by 3 and area as 3A. So you need to compare their resistances. What will be the relationship between their resistances? So to compare anything, we find out their ratios. So for this, we will find out the resistance. Let this be R1. Let the resistance of the second one be R2. And let the resistance of the third one be R3. Okay. So we get the value R1. We can write R1 is equals to rho L by A. Since all the three cylinders, they are made up of copper. Okay. And they are at the same temperature. So they will have the same resistivity, which will be given by R1 will be equal to rho times L by A. The value of R2 will be equal to rho times 3L divided by A by 3. So A by 3, and this will be equal to rho times of 9L by A. You can write it as 9 times of rho L by A. Okay, so we already know rho L by A is your R1. So you can write it as 9 times of R1. Right? Then we find out the value R3. R3 is given by rho L here is L by 3. This you have L by 3 divided by 3A. So it becomes rho L by 9A, and this you can write as 1 by 9 rho L by A, and rho L by A is R1. So you can write it as 1 by 9 of R1. Okay. So you can get here the ratio as R1, ratio R2, ratio R3, R1 we have, and the R2 in terms of R1 is 9 R1, and R3 in terms of R1 is 1 by 9 of R1. Okay. So if you multiply all with 9, so you get here 81. So you get your 9 ratio 81, 9 ratio 81, and a ratio 1. So this is the ratio of R1, ratio R2, ratio R3. Okay. The maximum resistance that is available is R2 has the maximum resistance. So who had sent this out? Yeah, Charvik, are you here? Hey, Subha Charvik.
Yes.
Okay. So doubt is clear?
Yes, sir.
Okay. So this is also an important question from the resistivity. I'm sharing just after the class. I'm sharing all this PDF also just now, so that you can re-look at these questions. Try to solve them again. If you are having doubt, try to solve them again and ask in the next class. Okay. Bye everyone.
Yes,
Good
sir.
night.
Thank you, sir.
Thank you so much.
Thank you, sir. Bye, sir.
Bye.